We're going to open up our unit on circles today by first going back and reviewing a little vocabulary, and then we're going to talk about tangents of circles. So what is the set of all points in a plane that are equidistant from a given point called the center? That's what a circle is. Set of all points equidistant from the center. Okay, what is the distance from the center of a circle to any point on the circle? We all know that is the radius. Two circles that have the same radius would be congruent circles. The distance across a circle going through the center, we know, is the diameter of the circle. And hopefully we all remember that the diameter is twice the radius. We'll put that up there. Okay, a line that intersects the circle in exactly one point is called a tangent to the circle. So, for instance, if we have this circle here and we have this line that intersects that circle at just this one point, this line would be a line tangent to the circle. There are an infinite number of lines tangent to a circle. The point where this line is tangent to the circle is called the point of tangency. Point of tangency. All right, a little bit more vocab. If we have coplanar circles that intersect at exactly one point, then those circles are said to be tangent. So they're tangent circles. Only touch at one point. Coplanar circles that have a common center are known as concentric circles. And a line or segment that is tangent to two coplanar circles is a common tangent. And we have a couple of kinds of common tangents. We could have a common internal tangent. So let's say we got two circles here. A common internal tangent would be one, well, that's not going to work out. Let's see. Got to go tangent to this circle, tangent. So that's really my point. Let me do that a little bit better. Should have drawn my line first. So there's a common tangent, and it's internal to these two circles here. Okay, so a common internal tangent, a common external tangent might look like that. Pretending like that actually intersected that second circle. Okay, common internal tangent, common external tangent. Okay, let's see. Concentric circles, I should probably draw a little picture of that up here. They have a common center, so if that's the center, any other circle that might have that same center would be concentric with that one. Okay, now we have many theorems in this unit. So I hope that you have not grown too weary of making your flashcards because you will want to do it. Excuse me. And by the way, this is chapter 12 in your textbook, so that's where you can find all these theorems. Okay, I have them all printed in your notes. So maybe as we go through these notes today, you might pause and look at the diagrams, read the theorems, make sure they make sense. I'm not really going to read every one of them to you. The first one we have just says that if I got a line tangent to the circle, then if I draw a radius, the point at which that radius touches that tangent line, well, the tangent line will be perpendicular to that radius there. Okay, that's theorem 12.1. And then 12.2 is just the converse of that. So if I know that the tangent line is perpendicular, if I know the line, not the tangent line, if I know this line, AB here, is perpendicular to the radius, OP, then I know that that line AB has to be tangent to the circle. Okay, so let's look at an example so that we can maybe use that theorem in its converse. What do we got here? Find the value of x. ML is tangent to the circle at L. MN is tangent to the circle at N. Okay, so right away, Sorry, the phone rang and I forgot where I was, but I think I'd read the whole problem. Okay, so we know that ML and MN are tangent, and these are the points of tangency. So because of the theorem that I just had, I know that those two angles there are right angles because the tangents are perpendicular. Okay, so what do we got? We have a quadrilateral, right? 1, 2, 3, 4 sides. So we know that the sum of all those interior angles is going to be 360. So the two right angles are 180. Then I got 117 for that other angle. So that's 297. So if I just do 360 minus 297, I should get the measure of x. That'd be 6. So 63. So x equals 63. Okay. All right, what about this one? Find the radius of circle C. The radius they have labeled x. They're telling me AB is tangent to the circle, and they've already got that angle marked as a right angle. So I just got to use the Pythagorean theorem, right? I have, let's see, x squared plus 12 squared equals the hypotenuse squared, which is x plus 8 squared. Okay, so x squared plus 144 equals x squared plus 16x plus 64. Got to square that binomial. Don't write down x squared plus 64 because you'll miss it. Okay, and then what I want to do is get everything to one side. And well, it's not going to be a quadratic, you know what? Because when I subtract x squared from x squared, those are going to go away. And so I'll have 144 minus 64 equals 16x. And then I'll have, that'll be 80 equals 16x. So x is going to be 5. So our radius is 5. Oh, that's a 5, 12, 13. Pythagorean triple. There you go. Okay, another theorem here. If two tangent segments to a circle share a common endpoint, like they do here, endpoint B, then the two segments are congruent. So let's look at an example with that. Circle O is inscribed. Oh, we've talked about an inscribed circle before, right? You remember in Unit 6, I think it was? Inscribed circle means I got 3 points of tangency. This circle inscribed in the triangle. The triangle has a perimeter of 88. What is the length of QY? So I'm going to call QY X here. That's what I'm looking for. And I'm going to use the theorem that I just learned that says, okay, let's look at PX, tangent there, PZ, tangent there. So the theorem I just read tells me that PX is congruent to PZ, so I'm going to label that. And then the same thing could be said of RY here. RY is going to be congruent to RZ, so I'll label that as 17. And I know that QX is going to have the same, it's going to be congruent to QY, so I'm going to label that X2. And now I'm just going to add all that up and set it equal to 88. So 15 and 15 is 30, 17 and 17, 34. So I got 64 there. And the other two pieces of that triangle would be x plus x, which is 2x, and then I know the whole perimeter is 88. So 2x is going to be 88 minus 64, which will be 24. Therefore, x, which is qy, which is what they're asking me for, is going to have to be 12. Right? I lost my place, but I believe that's correct. 12. All right, so what I did now is I included some problems. I did the examples. That's all the theorems that we're going to have in this little lesson here. So I want you to try to do these problems, the practice problems. I'll put the solutions up, and you come back and check your answers. Okay, here are your first two practice problems. For the first one, I got that the radius is 6 feet. Please take note of how I set that up. And then for the second problem here on this page, I used the theorem that told me those tangents to the circle with the common endpoint are congruent. I got 5 for that. So please pause here if you did not get those answers and check to see where you went wrong. On the next page, same theorem as the previous problem. I set the two tangents equal to each other because they're congruent. And this one was a little tricky. I got x equals plus or minus 3, and my initial instinct, I guess, was to think that negative 3 couldn't be an answer, because I always think in geometry the negative numbers don't work, but I went ahead and plugged it in, and sure enough, negative 3 is a good answer, not an extraneous solution. So you do have to have both of those solutions, and you can see over here where I checked both of those. So always be sure to check your answers when you're solving a quadratic equation. And then finally, I did the proof here for you. This is a really sweet little proof. Not that difficult, 7 steps. And I just used, what did I use? The only theorem that I learned today that I used is the fact that BD would be perpendicular to AD, and CD would be perpendicular to AD because they're tangents to that circle. So look through that and make a note if you have some questions you want to ask me in class. Write your summary and your essential question, and we'll see you next time when we will talk about chords and arcs, I believe.